What really happens? Inside a black hole, there exists a region in the universe where space collapses and time itself distorts, a region so extreme that not even light can escape. Welcome to Split Screen. I am your Professor Pilot. Today, we step beyond the edge of reality, not into science fiction, but into real physics. A black hole forms when a massive star runs out of fuel. For millions of years, nuclear energy pushes outward, balancing gravity. But when that fuel is exhausted, the balance breaks. Gravity takes control. The star collapses inward under its own immense weight. Layer after layer falls toward the center. What remains is an object so dense that its gravity becomes unimaginably powerful. Around every black hole lies a boundary known as the event horizon. This is the point of no return. Once anything crosses this boundary, escape becomes impossible. Not even light can move fast enough to break free. Now imagine that you are floating in space, slowly approaching a black hole. From a distance, nothing looks dramatic. If you remain far enough away, you can orbit it, just like planets orbit the sun. But as you move closer, gravity grows stronger. As you approach the event horizon, something strange begins to happen. To a distant observer, your movements appear to slow down, slower and slower. Eventually, you seem to freeze in time. This phenomenon is known as gravitational time dilation. It was predicted by Albert Einstein in his theory of general relativity. According to Einstein, gravity does not only bend space, it bends time itself. Near a black hole, time passes more slowly compared to distant regions of space. To someone watching from far away, you never fully cross the event horizon. You slowly fade and disappear. But from your perspective, time feels completely normal. And that is where the real journey begins. As you move deeper toward the black hole, gravity does not pull evenly on your body. Your feet, being closer to the black hole, experience a stronger gravitational force than your head. This difference in force begins to stretch you, longer and thinner. The effect becomes more extreme with every second. This violent stretching is known as spaghettification. The tidal forces grow so powerful that any human body would be torn apart long before reaching the center. However, the experience can be different if the black hole is supermassive. Supermassive black holes, like those found at the centers of galaxies, are enormous beyond imagination. Because of their immense size, the tidal forces at the event horizon can actually be weaker than those of smaller black holes. In that case, you might cross the event horizon without noticing anything dramatic at first. No sudden explosion, no instant destruction, just darkness. But once you are inside the event horizon, escape is no longer a physical possibility. It is not just difficult, it is mathematically impossible. In normal space, you can move in many directions, forward, backward, left, or right. Inside a black hole, all possible paths lead inward. Space itself is curved so extremely that moving forward in time means moving closer to the center. Inside a black hole, the word out has no meaning. At the center lies something called the singularity. The singularity is a point where density approaches infinity, and space-time curves beyond measurable limits. Our current laws of physics cannot fully describe what happens there. General relativity predicts the existence of the singularity. But quantum mechanics, the theory that explains particles at the smallest scales, does not completely agree. This conflict creates one of the greatest mysteries in modern physics. And the mystery does not end there. One of the greatest mysteries connected to black holes is known as the information paradox. According to quantum physics, information can never truly be destroyed. If you burn a book, the information is not lost. It is still carried within the particles and energy that are released. But if something falls into a black hole, and nothing can escape from inside the event horizon, what happens to the information about that object? Does it disappear forever? Or is the universe keeping a secret? If information truly vanishes, it would violate the fundamental laws of quantum physics. If it does not vanish, then where is it stored? Some scientists suggest that information may be preserved on the surface of the event horizon itself. Others propose that black holes slowly emit a faint energy known as Hawking radiation over unimaginable spans of time. A black hole may slowly lose energy, and eventually evaporate. But even if it disappears, the question remains. Where does the information go? We still do not have a complete answer. And that is what makes black holes so powerful. They are not just massive objects in space. They are laboratories that test the limits of human understanding. Right now, somewhere in the silent darkness of the universe, a black hole is twisting time and crushing matter beyond imagination. It does not fear our curiosity. But one day, human minds may unlock its secrets, because every mystery in the universe is simply a question waiting for a brave mind. And that is the power of science. This video is created purely for educational and informational purposes. Based on current research and publicly available information, viewers are encouraged to do their own research. If you enjoyed this exploration, like the video, share your thoughts in the comments, and subscribe to Split Screen